Intro. Imagine building servers manually every single time. Selecting AMIs. Opening ports. Creating SSH keys. Installing software manually. Now imagine replacing all of that with automated infrastructure using Terraform. In this video, we'll understand how AWS EC2 infrastructure evolves from manual setup to immutable architecture. Let's begin. The architecture of AWS EC2 and EC2 instance is more than just a virtual machine. It combines operating system images, compute resources, storage networking, and automation. Modern DevOps focuses on automating all these layers consistently. EC2 instance, composite AN. EC2 instance contains four major components. First, the AMI, which provides the operating system. Second, the instance type, which defines CPU and RAM. Third, EBS storage for persistent disks. And finally, user data scripts for boot time automation. This modular design makes EC2 flexible and scalable. Instance families: general purpose instances balance CPU and memory. Compute-optimized instances focus on processing power. Memory-optimized instances maximize RAM capacity. Choosing the correct instance family improves both performance and cost efficiency. Infrastructure maturity. Infrastructure evolves in stages. First comes manual setup through the AWS console. Then infrastructure as code using Terraform. Next comes automation through scripts and provisioners. Finally, immutable infrastructure using custom AMIs. The goal is repeatable and predictable deployments. Manual AWS console workflow. Manual infrastructure setup involves selecting AMIs, configuring storage, opening security groups, generating SSH keys, and installing software manually. This works for learning. But in production, manual workflows become slow and inconsistent. Terraform converts clicks into code. Terraform converts infrastructure into reusable code. Instead of clicking buttons, engineers define resources in configuration files. This makes deployments version-controlled, automated, and reproducible. This is the foundation of infrastructure as code. Security groups and SSH keys. Terraform requires explicit configuration for security groups, SSH access, and key pairs. Production environments should never expose SSH access publicly. Always restrict inbound access carefully. Terraform Provisioners. Provisioners allow Terraform to execute scripts during deployment. They help configure systems when Terraform alone is not enough. But provisioners introduce imperative behavior into a declarative workflow. That increases complexity and unpredictability. Local-exec versus remote-exec. Local-exec runs commands on the local machine. Remote-exec connects into the EC2 instance through SSH and runs commands remotely. The challenge with remote-exec is dependency on SSH networking, firewall rules, and authentication. This makes deployments more fragile. Creation time and destroy time. Provisioners. Provisioners can run during resource creation or before resource destruction. They automate setup and cleanup tasks. But every imperative command increases operational risk. Provisioner failure handling. If a provisioner fails, Terraform can either stop deployment or continue despite errors. Both options can create inconsistent infrastructure states. That's why provisioners must be used carefully. Breaking the state boundary. Terraform tracks infrastructure state carefully. Provisioners break that visibility because Terraform cannot fully track arbitrary commands executed inside servers. This creates infrastructure drift. The actual server may differ from Terraform's expected state. Anti-pattern versus best practice. Using remote-exec with SSH is considered an anti-pattern. It increases attack surface and operational complexity. A better solution is EC2 user data. User data automatically injects scripts during instance boot. This is cleaner, safer, and more cloud-native. Immutable infrastructure. Immutable infrastructure is the most mature deployment model. Instead of configuring servers after launch, everything is pre-installed into custom AMIs. Using Packer, engineers create golden AMIs containing software dependencies and configurations. Terraform then launches fully configured servers instantly. This reduces drift and improves consistency. Final comparison. Remote-exec is fragile and SSH dependent. EC2 user data is more reliable and cloud-native. Custom AMIs are the most scalable and predictable solution. This is the evolution of modern infrastructure. From manual clicks to Terraform automation to immutable infrastructure. Outro. If this video helped you understand AWS EC2 and Terraform clearly, subscribe to Data Enthusiast Era for more DevOps and cloud engineering content.